Okay, so 4-4. 4-4, like I said, is just adding a step onto the proofs that you already know how to do. So it's called Cpctc, which is a bit of a mouthful. I always just tell people, remember, every other letter is a C, and then PT, playing time, physical therapy, whatever you need to think of. There's a P and a T in between. Cpctc. Every other letter is a C, okay? Here's what it stands for, and if you know what it stands for, it's a pretty easy postulate to use. It is corresponding parts of congruent. This is a T, but I didn't leave a big enough space, so I'm making it a triangle. Corresponding parts of congruent triangles are congruent. Oh, this is so not neat. I'm sorry. Okay, corresponding parts of congruent triangles are congruent. Think about what that's saying. Okay, corresponding parts, meaning parts that match up on two different triangles. Corresponding parts of two congruent triangles will be congruent. So if I have two triangles that I proved congruent by ASA, for example here, okay, I know the two triangles are congruent. What this postulate or this theorem is saying is therefore everything about them is congruent. Every missing side, every missing angle pair will be congruent as well, okay? So if you know that two triangles are congruent, then you know that every set of corresponding parts is congruent. That means all of their sides and all of their angles will be congruent. So if you think about it in terms of this picture, you have angle, side, angle with angle, side, angle, right? So I know this to be true. Triangle ABC is congruent to triangle DEF by ASA. Since I've proved the triangles are congruent, now I can say in my proof, anything I want to that matches up is congruent, right? So I can then say that segment BC is congruent to segment EF. Whoa, sorry. I can also say that segment AC is congruent to segment DF because I've already proved the triangles are congruent. If the triangles are congruent, everything about them is congruent, okay? What's the last thing that I can say then? It's right here, right? If I know the triangles are congruent, then angle C would have to be congruent to angle F. So it's kind of like what we started the chapter with in 4-1. All three sets of angles and all three sets of sides are congruent, okay? Because we proved the triangle's congruent, therefore, everything about them is congruent. Cpctc, okay? The beauty in this is it's pretty easy to tell when Cpctc is going to show up in a proof. Let me show you why. So far, if you think about how we've done proofs, it's been given this information, prove what? What have we been proving as our final step? Triangles congruent, okay? So whenever you have triangle something congruent to triangle something, it's SSS, SAS, ASA, AAS. Now, we're going to take it a step further. So we're not proving triangles congruent anymore. We're proving parts of triangles congruent. And if we are proving parts of triangles, so if we're proving an angle congruent to an angle or a segment congruent to a segment for our like prove thing, your last step almost assuredly is going to be Cpctc. Okay, so if you're proving triangles congruent, SSS, SAS, ASA, AAS. If you're proving angles congruent or segments congruent, your last step is most likely Cpctc, okay? So let's take a look at these proofs. We have two, and then we'll see how you're feeling about it. Biggest thing you can do with this stuff, you guys, and I've said this, I'm sure you think I sound like a broken record, but mark what you know. Mark up your triangles. So if you look at your given here, oh, we still have a highlighter, sorry. RS is congruent to UT, mark that. RS congruent to UT, okay? Then it says RT congruent to US, mark it. Now you look at your picture here, okay? We're trying to prove that this angle here is congruent to this angle here. Don't mark that. We don't know it yet, okay? I'm just showing you. But just make sure that you don't mark it and then go, oh, it's SAS. This is not SAS. We're trying to prove that those two angles are congruent. So we need to find a different way to get there. Does anyone see, so we have our given, right? That's step one. Does anyone see another piece of these two triangles that has to be congruent? Nolan. Right, so mark that, okay? We can say that RU is congruent to RU. How do we know that? It's reflexive. Okay, now look at your two triangles. What do you see? Side, 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 right? This is S, S, and S, 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 and S. So you have side, side, side. What do we say is true by side, side, side? Right, you got to set two triangles congruent. So if we say triangle UTR, then you have to be real careful about which triangle that's congruent to. So if I went U to T to R, I went through the one hash mark through the two hash marks. So you need to do the same thing on the other one, which is which triangle? RSU, good. Okay, so normally this is where we stopped, right? We proved that the triangles are congruent, but we're not trying to prove the triangles are congruent now. We're trying to prove the angles are congruent. So how do I know that this angle T is congruent to that angle S? Cpctc, right? We proved everything about the triangles has to be congruent, therefore those angles will be congruent. So angle T congruent to angle S by Cpctc. Questions on that? See, that's not so bad, right? Just one extra step on the end. Okay, let's look at this one. Given that angle R and angle V are both right angles, so they tell us R is a right angle and V is a right angle. We're also given that RS is congruent to VS, so mark those congruent, RS congruent to VS, and we're given that RT is congruent to VU. Okay, mark up what you know. All of that was our given. What's something we have to say yet about these two triangles? Nolan.
Is S the midpoint?
They don't tell us that S is the midpoint, and really we don't need that because they already told us these are congruent. So we don't need to prove it's a midpoint in order to do that. It is because they're congruent, but we don't need that part of it. There's something else we have to say before we can say the triangles. Right. If they told us these are right angles, then we can say that they're congruent. So angle R, would be congruent to angle V because all right angles are congruent. Okay, so mark that, right? Mark it congruent, this congruent to that. Now what do you see? Triangle SRT is congruent to triangle SVU. Why is that? That's side angle side. SAS with SAS. So that's by SAS, okay? They're trying to get us to prove that angle T is congruent to angle U. You don't need to mark that, okay? We've already done the work to see why that is. We can say that now. Angle T is congruent to angle U. Why? Cpctc. Okay, because we proved the two triangles are congruent, everything about them is congruent. So technically right now, I could also say that ST is congruent to SU by Cpctc. Or I could say that angle RST is congruent to angle ASU by Cpctc. So there's a lot of things that we could say are true by Cpctc. We don't have to because they didn't ask us to prove all of that other stuff, but we know that those things are true. Okay, that's Cpctc. Jason.
Finding this half the triangle and the other half.
Right, by finding the three parts, we know the other three parts will also be. Yep, it's a good observation. Any other questions on that? Okay, just a couple last things. In every proof, make sure you mark up your triangles, okay? If you don't mark it, then you might think in your head, oh, it's AAS, but you marked it wrong in your head. If you mark it on the triangle itself, you see where you know what you know, right? Then you can see, is it SSS, SAS, ASA, AAS, whatever. Number two, you always need to know where you're going. So when you start a proof, look at what it is they're asking you to prove. If they're asking you to prove triangles congruent, okay, if it's a triangle congruent to a triangle, it is going to be SSS, SAS, ASA, or AAS, okay? If they say segment congruent to segment or angle congruent to angle, what's it going to be? Cpctc, because you're proving parts of a triangle, not triangles themselves, okay? However, if you have Cpctc, it's only because the step before it is what? One of these, okay? So you will never have Cpctc before you've proved the triangles are congruent. It will always go SSS, SAS, one of those, and then Cpctc. Okay, you can't have Cpctc without already having said triangles are congruent. Questions on that? All right.